Well, once I had this computer done, I had the BASIC running to some extent. The first program I wrote, it wasn't even a game actually, it was a program to help me design some pseudo-random shift registers for my calculator circuits at HP. So it was actually a real useful use of a computer. Although most of the computer features were designed by their applicability to running games. Anytime you went to a computer open house where they use computers for scientific or research or industrial needs, what do they do at an open house? They have the computers running games. Any computer that can run a game is a complete computer that can do everything else. That's the corollary. Well, I went to Hewlett-Packard and said, look, we can make a product. We can make a product, and if you take the plastic case and the keyboard and a microprocessor and so much ROM and so much RAM, it was sort of like our calculators. That's what they were. They had a microprocessor inside, they had ROM, and they had RAM, and they had a keyboard that was on. The instant you turned it on, the keyboard was paying attention to it, and a little display. So this was just like a growth of calculators. I said we could do it for $800. And the lab manager, who had had a lot of experience being a major lab manager out here in Colorado, he had actually managed Hewlett-Packard's first desktop computer that ran BASIC. And it generally a system sold for about $5,000 to $10,000. Way too expensive for an individual. But it was a desktop BASIC computer. Boy, he was intrigued by what I said. He lost sleep for weeks thereafter, but he couldn't quite justify the use of the resources or that there wouldn't be technical problems or maintenance problems or support problems, and he said it was sort of the right thing for an outside company. HP's legal department did a nice little 3-day scan of all the divisions, came back and said nobody at HP is interested, so here's a legal release. It was really odd because after getting the Apple I going, right here in our calculator lab, I noticed that some people who had some experience in designing circuits were starting to design a little 8-bit microprocessor. Some people who had experience in programming, there were 5 people writing a BASIC, and I had just written one myself. Then there were people working on a printer interface, and people working on a cassette tape interface, and memory, and all this stuff, everything I'd done for the Apple I. And I saw this project start up, and it had 14 people on it. It was called Capricorn. And I was selling Apple I's by then, but my life my interest in life was no longer calculators, it was computers. I went to the lab manager, it was a new lab manager. And I said, I want to work on your computer project. And I'll do anything. Just because I've done a computer, I don't have to be the central guy. I mean, I'll do CPU or memory or printer interfaces, I'll do cassette interfaces, I'll help write BASIC. And they turned me down, which was one of the few very negative things that was sort of in a sense wrong that I ever saw at Hewlett-Packard. When an engineer is dissatisfied with what they're working on, wants to work in a different area, they should go there for their own growth potential. So I was turned down there, and I was also turned down at Hewlett-Packard Labs on a project that was going to be a little BASIC computer because I didn't have enough education. So I struck out 3 times at Hewlett-Packard and had to do it on my own. Anyway, I was going down to the club. And in the spirit of the club, we're just doing a lot of this stuff to be interested in a changing technology and people getting computers in their home. We believed the home revolution was occurring. Every single home would have a computer. And what did a home computer comprise? By definition, it had 3 wires that went into your oven and a program that had recipes. To the technical hobbyists of the early days, that's what a home computer was, not what it turned out to be. So they were a little off. I was passing out schematics at the local club. I would even help people hand wire them on occasion and make their computers, make their terminals, because a lot of people were interested. Steve came along one day and he said, look, all these people are interested in schematics, but it takes them 10 hours if they know what they're doing to put one together. And God knows if they can figure it out and test it. He said, why don't we make a PC board? A PC board, and it'll have a silkscreen legend on it telling them where every chip goes. And we'll just sell it for $40 at the club, and people will buy the PC board. They know where to get all the parts at the local surplus stores, and they'll plug the parts in, solder it together, and it will only take them a couple hours to make. And, we sat down and thought about how many people did I think in the club were really going to buy this $40 PC board that cost us $20 to make, and would we get our money back, and we'd have to pay a guy to make the PC boards. We figured out that it might take about 50 people buying them to break even. I didn't think we'd do it. Steve said, yeah, we'll lose our money, but at least we'll have a company. And I'll tell you, that's a good enough reason to do it. If you're trying to justify it in dollar terms, it did not go. But in terms of just feeling, once in your life you had a little, on the side, company, that's sort of a neat thing that everybody really wants a part of. So we did it. Originally there were 3 of us. One guy helped out doing our first manual, and he had 10% of the company. Steve and I each had 45%. And then if there were any disputes between Steve and I, we both trusted Ron Wayne to resolve them. And he decided that once Steve started getting orders for large amounts of, once we started selling completely, we were going to sell blank PC boards at first for 40 bucks. Once we got orders and we're selling $500 completely built computers, he got worried because Steve was committing ourselves to all these huge orders of parts for thousands of dollars, and Steve and I didn't have anything. You know, I mean, we barely had, minimum down payment on a car, for me, one of us, and he had money. So he knew that he was the only one that in the end, in this partnership, was gonna get nailed. So he sold out his 10% for $800. Well, I was at work one day, and we were planning to, barely make back our $1,000 by the time we made 100 PC boards, and we had made the first 3 boards, and I was showing them off at work to the other engineers and glowing over. It was the most beautiful artistic PC board I'd ever seen in the world. I look at it now and it was really pretty cruddy. But Steve called me on the phone and said, "Guess what?" I said, "What?" He said, "I got an order for $50,000. Okay, and of course I was floored. He hit me with the big one. And I said, "What?" He said, "The local computer store, there was only one in our area, they'd been buying these computer kits, assembling them in the back room with their own technicians and selling them at a higher price. And that was, basically, they wanted a computer completely assembled." Well, so basically, our computer was all on one PC board. Just had to stuff all the parts in and put it over a wave soldering machine, and it was completely done. And the user only had to connect 3 things: a keyboard, a monitor, and some transformers for power. It turns out we found out that it only cost $13 to pay a company to stuff all the parts in and wave solder it. It only cost $13. We were wondering, why are all these kits being sold? Why would you not pay the $13 and make sure everybody gets a completely assembled computer? The people that were starting this little business had no idea. They came out of the hobbyist world of heat kits, and they thought that somehow that was a big cost savings benefit. It was really a drawback. So we were going to sell the most assembled computer of its day. It did not have a case on it even. It was just a plain old PC board. I mean, it came from, my thinking and the rest of the Homebrew Computer Club thinking was pretty much along the lines of, if you had a whole bunch of wires strapped across your living room floor, running into your TV set and clipping into your phone with alligator clips all over, and it was gonna burn down your house someday, that was fine, because it was usable. That was a computer, and you could really use it. And it didn't matter at all that it had to be, you'd have some sort of looks or some sort of product value. And that was where I came from. And Steve came more from a thinking of trying to get to a product that could be sold en masse and be a part of a big market that was about to happen as a real product that you can deliver and other people can use besides just we few freaks who couldn't afford it. Okay, anyway, we had to build our first Apple I's once we got this large order. And we had to buy a lot of parts. And Steve was very persuasive and talked the local parts suppliers into giving us credit based on he had a purchase order that was signed by the local store. So he said, if we pick up the parts, we'll build the computers, we'll sell them to the local store, and they called the owner to make sure, and we'll give you the money, and we'll get it to you real quick. So what we did was, we arranged everything. As soon as the PC boards came off of the assembly line, at the same company, the parts would go over, and they would start stuffing the parts in, and then they would wave solder it right there, because they did it right there, and then we'd pick them up a couple days later, take them to the garage, plug in the last integrated circuits, and Steve and I would race, and I usually won. I always won. And then, I don't know how you remember these things, but anyway, we would test them out, and we'd box up the working ones and drive them down to the local store. And we discovered that from when we get the parts to when we get the computers delivered to the store and get our check was 10 days. And we had 30 days credit on the parts. We had 30 days to pay them off, and we ran the whole cycle in 10 days. It's amazing what you can do when you got one level of management. Actually, the airline schedule tonight probably wouldn't bother most people who have to keep schedules for technology companies. Anyway, with our Apple I computer, a whole bunch of all the computers coming out, it was the most assembled one. It was also the greatest value per dollar. To buy the computer that everyone wanted really had video in it, and we had it built into the Apple I. There was only, preceding the Apple I, there had only been one other low-cost computer introduced by a company called Sphere that had video built in. It was sort of acknowledging the computer for the home has a video terminal. It talks to a TV set. So we were on one of the leading edges there. We also had 4K of RAM memory, 8K of RAM memory on our board. I had designed it for the state-of-the-art RAMs of the day. The smallest chips, the 16-pin ones, were the ones I chose. Why? In my computer education, a computer value was measured by, or how good a job you did was measured by how small a board area it took, meaning how few of components. But if you used a smaller chip than another size chip, you could use more of them. It was square inches was what I counted as important. And so anyway, I used the right RAM chips. All the other computers coming out were not being designed by professional engineers for their companies. They were not well-managed projects. They were using the simplest to design parts you could buy, the 2102 static RAM. But the problem was the 2102 static RAM was only 1K. And the new dynamic RAMs, which were harder to design for, were 4K. But the hobbyist mentality is slow to move towards the state-of-the-art parts and the design, the sophistication that's involved. So we were the only computer that was introduced with those dynamic RAMs for maybe a year and a half after we started using them, or even maybe 2 years. After the Apple I, we started shipping it and we got known. All the magazines were starting to follow this. Something's happening in microcomputers. There's all these kids coming out, and electronics magazines love to print an interesting article comparing them all. Well, the Apple always looked pretty good for amount of memory, features, speed, video built in, you know, the power supply was built in. I mean, it just always came out very good, and that was a good motivator, getting positive feedback like that. And it got us known, even though we only sold a couple of hundred of them in a year. It got our name known, and we had a good respect for our image of ourselves nationally. Was good. I started working on adding features to the Apple I. I had designed it to add color by choosing the crystal frequency to be, that it ran out to be exactly right for American color TV. In working at it, too many things, all of a sudden, in one few-month period, optimization after optimization, just sharing this memory with that memory. A little trick here with one chip replaces 5 others with a real clever thing it wasn't designed to do. So many optimizations happened one after another. I wound up with a little computer I could take down to the club that was half as many chips and twice the power. Basically the Apple II. The feature selection of the Apple II was not driven by saying, what do people want to use for what purpose? What do they need? How many characters on the screen was decided by one factor only. How many characters fit on a home color TV? The Apple II was the first of the low-cost computers to have any sort of interface available, even if you counted what weren't standard features on the other ones. It was the first one to say the starting input-output device is a home color TV. It was the only one that would work in that mode because that's what shows 40 characters across in the character selection. The end goal was to be very few chips and to be inexpensive. Even things like having the screen has a whole bunch of addresses. They go in a jagged pattern as you go up and down the lines in an Apple II. The reason for that selection, it saved me 2 chips with a clever little implementation. If you can take it down to the club and show a 30-chip circuit instead of 32, that's a little bit of a plus. The computer was not being designed to be a product, and it was not being designed to be sold nearly as much as it was being designed to impress and do some very unusual things that had not been seen before. So many optimizations converge on the Apple II, from the way the bus worked out, to the number of characters on the screen and all this. It had a lot of firsts. When we finally shipped the Apple II, looking back, it seems like, well, it was just, standard technology of the day, which it was. But it's very unusual to find that a few major things were done for the first time ever. Standard parts of a low-cost computer, first time ever, and yet they've been in virtually every microcomputer since that's been successful. It was the first one to have BASIC included in ROM, the very first one. BASIC is built in. The first one ever to have a plastic case. The first one ever to be completely assembled. All you got to do is plug it in the wall. The first one ever to have 48K of RAM built in on the motherboard where you don't even go to any slots. That was unheard of. All the other computers, you had to start plugging in like 1K and 2K boards into every slot to add it up. We had gone for the state-of-the-art dynamic RAMs. It was the first one to have color. It was the first one to have paddles. The first one to have sound. The first one to have graphics. And the first one to have high-res ever. Ever. This had not been done in a low-cost computer ever. Peripherals had been designed indicating these things in some of these areas, but they were expensive and not built into standard features. One of the hearts of the Apple II was we recognized that a lot of things that made good sense that were cheap, you could put in for one chip, put this feature in for one chip, put 4 panels in for one chip, everything that could be put in for almost no cost that made sense intuitively was right to build in as much as you can. The advantage of the Apple II was it didn't leave a lot of things to slots that we could build in cheaply. It left enough slots for expansion that was going to come beyond what we could think of. In other words, whenever you can recognize standards that are going to exist and prevail, build them in. And that works up to even this day with products like our Apple IIc and Macintosh. We decided that with this Apple II might just be the makings of a big seller. We might have a product that we could sell thousands a month instead of 10 a month. And we decided we needed a company, not a partnership. And a company means you got chairs and telephones. So we decided we're going to set up a real corporation. Well, there's a problem. You start thinking a number like 1,000 computers. We could sell. Steve Jobs was doing all the marketing out of his home. He was running the whole company, doing all the scheduling, getting the parts. I was just designing stuff at night and designing day and night, I should say. But I also worked for Hewlett Packard. I was moonlighting. We couldn't pay ourselves salaries. I had to moonlight from Hewlett Packard. Steve lived with his parents. He didn't need the income. We couldn't pay ourselves salaries from the Apple I. We wanted to build 1,000 Apple IIs, but they cost $250 each to build. How do you get $250,000? You know, when you have to pay cash at your apartments. Well, it turns out that we started looking around for venture capital, and Steve checked with some friends at Atari, and they led him to one connection after another. We talked to them in the garage. The best thing that I could come up with was a very intuitively right sense, but it has no meaning in the business world. My feeling was, look, there are over 1 million ham radio operators, and computers are more popular than ham radio, so the market's going to be more than 1 million units. That was how I came up with my market estimate. There is no way in the world that something that absolutely right could be wrong. There is no way. No, it was true, because I had been a ham radio operator, and I knew the connection. But that's one way of thinking that doesn't have rules that you're taught in business school. We had trouble getting money. We finally ran into Mike Markla, and he had retired at a fairly young age from Intel. He had a good stock option there. He made his $1 million, so he got out of the rat race, but he kept paying attention to electronics. One dream of his life had been computers in the home to store recipes on, of course. But it had been a dream in his life. Anyway, he looked at the Apple II, and he was going to first at least he portrayed that he was just helping us write a business plan, and he knew who to give it to get more money. He knew some venture capital people. How would he go about it? He was only trying to help. The guy was so pure and sincere. He was not the sort of person who just goes in and takes advantage of young, naive kids who don't know anything about business. He finally started realizing that the analysts were predicting a new market was going to blossom and go from zero to billions of dollars in a few-year period. Only when new outlets and new distribution channels, new stores are coming up that don't already have connections with companies that are supplying them products for their bread and butter revenues is a chance that a new company can come in and not nick away a percent at a time of the business, but can grow at the same rate. You can grab a good percentage of a market and grow at the rate of the market if you do everything right in marketing terms. And he was a marketing person. So he finally wasn't going to let any venture capital get this deal. He wanted to buy in as a third partner. And he was going to have 20%, and Steve and I would each have 26%, and the rest would be divvied up to other employees. So he loaned us the $250,000. Just basically in one day, just loaned it over. He trusted the product was that good. He went down with me to Intel's executive staff to show it off, and he was very proud of it. He told me that there was one little hedge, I'd have to quit HP and make Apple 100% of my life. And I said, wait a minute, in less than a year I designed the Apple I, the Apple II, I wrote a BASIC, I wrote 2 monitors, I wrote all these demonstrations, I designed cassette interfaces, printer interfaces. I said, I did all this stuff nights, part-time, highly motivated. I could still keep my job at HP for a while for security. And Mike said, no, you gotta leave HP. And he gave me a date that I had to make a decision. And I thought about it. Boy, I had things pulling me both ways, and I finally decided I was gonna stay at HP. And I told him that on the ultimatum date. And Steve got a little bit panicky, and he got all my relatives and friends to start phoning me. And eventually they talked me out of it, because really I realized when one friend, good friend at Apple, that had actually helped me on part of the Apple design, he worked at Hewlett Packard, and he basically said something to me that it clicked. I can remain an engineer my whole life. I don't have to feel obligated to go into management to become rich. I can feel like I'm going to be an engineer and just do all the engineering I want to do, even on the side. My projects will be as good as I ever wanted to do them. And in the meantime, I can have a company and try to turn it into revenues and dollars. And I don't have to go in to be a management and a company runner and a businessman in that sense. So I finally turned around and said, okay. First Apple II was a pretty minimal machine with 4K of memory. But then, see, people started writing programs that needed 1K of memory at first for a little basic game, and then 2K, and then eventually they spent enough time and wrote one that needed 4K. And by now the Commodore and Radio Shack computers came out. There were 3 of us, all positioned in a, anyone could win the race. What happened was, all of a sudden software needed more than 4K of memory, more than 8K of memory. Things like VisiCalc came out by about '69, and floppy disk came out from Apple. We were the first ones in the personal computers to come out with a floppy disk that required more than 8K of memory to run. And these other computers had been designed non-expandable, without the slots to grow in directions that they didn't think were going to happen. And the Apple II had 48K capability built in. So all of a sudden these programs were so significant a market force that the other companies were left behind and Apple took first place, only because they could not expand their memory. That was the major factor. They had to go back to the drawing boards, reintroduce their non-compatible computers a year later. That's how we positioned ourselves as the leader. The distribution channels, all the computer stores were emerging, and Apple was the leading candidate. We had good marketing staff. Most of the little startup hobby companies were a couple engineers like me and Steve Jobs. Design a product and write a little ad and put it in a hobby magazine, and maybe you'll sell some products. Mike Markle knew what sort of deals you had to make to what distributors and the contracts, how they should read. He'd been through all this at Intel, so we got established very well. The major, I'll give one more story before I turn the mic over and give everybody a little bit of rest maybe. The floppy disk development was a very crucial part of Apple's development, even to this day. It came about a little bit by accident. We were running for about a year. And Mike Markula, who was our marketing guy and our chief financial guy, had one major thing he wanted to do: computers in the home. He made sure that our first ad showed a guy working on a checkbook on the computer. So he got Randy to write a program in BASIC, in our integer BASIC, to handle checkbooks in the home. There was one problem. We didn't have floppy disks in 1977 when we introduced it. We had cassette tape. So you'd sit there and load your program in for a few minutes, then you'd load your checkbook data in for a few minutes, you'd change one check, and then you'd store it back out for a few minutes. It was a little bit long for one check. I think the paper method was a little better. Well, Mike Markle went to an executive staff meeting one day, and this was his pet project. And you get tied a lot closer to your pet projects all throughout Apple's history. The pet projects are the ones that have made it or gone the farthest or been the ones that got the most attention, until the person whose pet project it was got dismissed. But anyway, Mike Markle went to the executive staff meeting, wrote down 20 things that we needed most to add to the Apple II. And first on the list, floppy disk, because that's the way his checkbook program was going to run fast enough to make sense. And number one was floating point basic, actually, I think. Or number 2 was floating point basic. So you could actually write dollars and cents in floating point instead of integers. And that would solve the programming hassles. Well, I went out of that meeting and I said, I'll look at floppy disks. But I had never taken a course or read a book on how floppy disk controllers are designed or what they do. I had no idea how to find out what they do. I was going to have to explore it from the bottom up and try to figure out what will at least work and appear to do the things that all the others do, since I don't know how they work. I studied a competitor's schematics, and I started looking. I'm trying to figure out why I'd come up with a clever little circuit back at HP that would read and write data at about as fast as I thought a floppy disk could go, and yet this circuit only took 5 chips. And I was wondering, why is every controller in the world 50 chips? I've got to put in all the right things. I started studying their schematic, and I went through and I figured out what every little chip did, and in the end I figured out my little 5-chip circuit actually did more. So I knew I was onto another winner. Very highly motivated. The first consumer electronics show that was going to allow microcomputers was coming up in January, and it was now late December. And Apple was going to go to Consumer Electronics Show in Las Vegas. You know, to me, I'd never traveled outside of California hardly, except for a year in Colorado. And, you know, other people like Randy. Las Vegas was flashing neon light, the city of glamour. It's like a dream. It's a myth until you've actually seen it. You really, you just know it is a place. It was so much of a dream. We wanted to go, and we thought that a good justification for going would be build a floppy disk. Maybe we can demo it there. So we came in almost every single day of Christmas vacation of that year, and I would work on some hardware, and Randy would write some software to help initialize the tracks, and we were going to put together a little demonstration program. Apple came back to work in early January and was sort of surprised. It's all here. Look, we almost got it all done. We almost got the last code done to where we can run programs from it. And they were a little bit surprised, but they said, okay. Mike Markle said, okay, let's go show it at CES in Las Vegas. So we went out there, and on the way walking down to the convention center, we'd always take breaks and go gambling a little. Randy was probably 16 at the time, and he actually won $35. So luck is a factor. Anyway, we went down to the convention center that night, and we were putting together one demonstration disc, sector by sector. We would load it in off a cassette tape and store the sectors, one sector at a time. And we had to make the disc perfect because it was so quick, we didn't really have time for a full-blown operating system yet. It had to be perfect. We didn't finish till 6 in the morning, and it was demonstratable. And Randy was pretty smart, and he said, well, let's make a backup. We're both so tired. And one thing is you got to recognize when you should make a backup. You should make a backup when you're tired, but you shouldn't let your tiredness cause you to write onto the good disk, which is what we did. Anyway, we recovered and we showed it. The next time we showed the floppy disk was the first time NCC, the National Computer Conference, was going to be held in Dallas. And Randy and I got to go again, sit in a booth and show people our computer. And I can't remember if we even attached the floppy disk that time, but the thing, you don't remember things like that, because that had relevance to the company and the business. What you do remember is a couple of jokes you played. Sure enough, I got into my room, and it was the first room I'd ever seen in a hotel that had a little thing where you could dial a movie, and it would pop up on your TV set. I'd never seen one of these in a hotel. But I said, wait a minute, I designed one of these for a company down in Los Angeles while working at Hewlett-Packard. It was one of my little sidelines. So we always carried our tools back in those days. So I took it apart and opened it up, and sure enough, there were some dip switches inside. And I said, well, that's how they send your room number down to the computer. So anyway, somehow we didn't get billed. If any of you were there and got billed for a movie you didn't watch, I apologize. Then going out, there was a touch-tone telephone. So I disassembled it and I put it back together so that the numbers went 1, 2, 3, 4, 5, 6, 7, 8, 9 vertically. And boy, you'd look at it, you didn't know that anything was really wrong with it. And if you wanted the bell desk, you'd punch 4, and it was right up there. I don't know why they got you always got room service. Anyway, a lot of where Apple came from had a lot of the hacker ethic in it. Going out and trying to achieve the perfect little tight program that, after hours and hours and hundreds of trials, you finally converges on one that is so right, click, 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 that it's the right way. And almost every other hacker, high-level hacker, would sort of agree with you on that point. A lot of purity about information should be shared. Pass it around. Let other people look at what you've done and try to build on it and do a little bit better, an improvement, an enhancement, add a feature to it. And you can build on theirs. A lot of make the information, the code, the listings, the schematics very public because people can take advantage of it and do a little more. And that's the right way for the hacker ethic. And there's a major book coming out called Hackers, Heroes of the Computer Revolution that gets into that topic through several generations of hackers, going back to some of the most pure ones at MIT back in the first days you could ever get close to a computer. So I'm gonna let Randy come up here and talk a bit because he can talk about some of the Macintosh development history. And he wrote the word processor Mac Write, and it's very incredible to hear some of the stories of that history. I don't know it all myself. I don't know what he's gonna say. And But anyway, Randy came with us from before we even had an employee. He was an employee. So listen to him briefly, and then afterwards we'll both be up here to answer questions for you.
I was just with Apple for a whole lot of years. I came into it right out of high school. As a matter of fact, I'm the only person in the world who could ever claim that he had all the employees of Apple at his high school graduation. That was 6, but that's okay. And after that, just stayed with Apple and did Checkbook, worked with Steve on Integer Basic and a bunch of demos, did AppleSoft, I worked with Steve on the disk drive, a few other projects that will remain nameless at this time. Eventually what happened is that I actually quit Apple, and because I wanted to go back to college. Everybody needs college education to get anywhere in life. And one day I got a call from Steve Jobs who says, you know, we need a word processor on Macintosh. And I said, well, you know, I don't want to do it. I want to go back to school. And he gave me a price, and so I said, well, okay. Since you asked nicely. Other than that, that's what I've been doing actually for the last 2 years, going through the definition of Macintosh. I'm just one of a number of people at Apple who we're real proud of the Macintosh. A lot of blood, sweat, and tears went into that machine, to say the least. The only interesting story I'll fill you in on is that Macintosh was introduced on January 24th of this year, and we had planned on having all the software shipping off to production on about December 12th or something like that, because it really needed that much time to get in all the machines. And I had 2 people working with me on the word processor, and one of them I said, oh sure, you can take a 5-week vacation in Spain in late December, because we'll be done by then. Well, beginning of December comes by, and we're still a long ways away, and Ed, that was the guy, he goes on vacation, he's over in Spain having a great time. There's only 2 of us left there, and the date keeps slipping, and January 2nd's the date for sure. Well, January 2nd comes and goes, nobody's ready. January 10th is the date, can't slip. Finally comes down, January 18th is the day that the software shipped out of Cupertino. And it was actually on dealer shelves on January 24th. There was a lot of postage paid for that event. What was pretty amazing is that on January 18th, it had to go out at 6 o'clock in the morning. And at 2 o'clock in the morning, none of the software worked. I mean, there were, it was like the worst scenario you could possibly imagine. Mac Paint had crash bugs, Mac Write had crash bugs. The Finder, you couldn't even copy a disk. I mean, you know. And the ROM had all sorts of bugs, and we did manage to pull it off by 6 o'clock in the morning. It was pretty amazing, and if you ever have to go through something like that, I feel pity for you.
Well, after that year of college, came home and was going to a local college back home, designed a little computer of my own. I designed a lot of computers, but I could never talk the local silicon companies, the local integrated circuit companies, into giving me the parts I needed to build my own computer. I was a little too vague on what I needed. So anyway, I finally designed one and managed to get Signetics, I think, to give me a few parts. And it was a very tiny 8-bit computer. And what it was when it was done was it was pretty small. It had a bunch of switches on the front and a bunch of lights, just like mini computers. And it had an instruction set of my own design. And what you would do to load a first program into it, let's say you wanted to load a program in that was 20 bytes long. You would toggle the code for one of the bytes on the switches. There were no such things as video terminals back in 1970. There were no such things as affordable teletypes, and I had no money at all. I had to use what I could beg and borrow. So the only input device was these switches, and you'd toggle a code on them, 1 byte, and push a button, and the byte would go into memory, where you wanted it to. You'd toggle another code, push a button, and that byte goes into memory. And you could load a little 20-byte program into memory. Maybe it did some little tricky thing like a multiply. And you could push another button, and it would run, and you could actually watch it working. And it turns out that it didn't matter, that it did nothing useful. It did only something that I knew this was a computer. That was the only thing that matters. All the rewards of computers were intrinsic. It didn't have to accomplish something to the outside world. It didn't have to earn money. It didn't have to start a company. It didn't have to get a career or get a job. It was a computer, and I was very proud of that. The trouble is, after it was done, you sort of think, well, what can I do beyond this? What can I do next? And the ideas that came into my head, and a friend that was working on it with me, were, you can add a keyboard, number 1. And I started thinking, I had no money. You've got no money, what sort of output device can you possibly get? You cannot afford a teletype to print answers out. And the video terminals were not around yet. Well, I started thinking, and I finally figured out that I knew how to build a little circuit that could, if I attached it to my oscilloscope, I could always borrow an oscilloscope, and it had X, Y coordinates. And I could just draw that trace over and start drawing characters. So I started designing a circuit that would print numbers only, onto an oscilloscope screen, but never got around to building it. It was an important stage to go through in 1970. The rest of the world was going to go through that stage in 1975. Next, around that time, the friend who helped me build that cream soda computer, because we drank cream soda all the time while we worked on it, introduced me to another friend of his, Steve Jobs. The reason he introduced us was we had a couple things in common. We had gone to the same high school, although we didn't know each other, and we had electronics and pranks. Well, one of the first things, you know, Steve and I just talked about all sorts of electronic issues and counters and where you could get LED displays and drivers and all this. So we were heavily into electronics, fun for ourselves. Nothing, you know, official or serious. One day I picked up a magazine and I started reading a story about phone phreaks and blue boxes. A blue box, in theory, this was a fiction article. It was labeled fiction. But a blue box was a little device that put special tones into anybody's phone, and those tones would start making the entire phone circuitry of the entire phone system of the world connect you anywhere you wanted, on any paths you wanted, and go around the world as many times as you wanted. And somehow you could, it was the most amazing fiction I'd ever read. And the heart of this fiction was an engineer named Captain Crunch. And supposedly, if you read this thing, he drove around the country in his VW van, packed with racks of electronics equipment because he was the brightest telephone engineer that ever existed. And he would clamp into payphones out in some lonely Utah desert, Colorado desert. And he would start setting up networks with 20 different phone phreaks, all talking to each other, sharing information, passing codes, and connected all over the world. And it was an intriguing story. Before I was halfway through reading this piece of fiction, I called Steve Jobs on the phone and started reading it to him over the phone. How Captain Crunch would talk about, I'm not in it to hurt Ma Bell. I only want to explore the system. The phone company is a computer, a system, and I like to explore computers and find all the little bugs and where all the little alleyways of this whole system go and find where the network connects. And I don't really ever want to hurt Ma Bell, kind of a love-hate relationship. And it was just so intriguing to read this kind of stuff. Well, as I was talking to Steve Jobs on the phone, it occurred to me that, wait a minute, they're giving too much information about certain frequencies and certain codes. There's too much information here. This doesn't sound right for a fiction. And so we decided to go check some of it out. So on a Sunday, we went to, where's a technical library you could sneak into on a Sunday? Well, we picked the Stanford Linear Accelerator Center. No question, you go to any of these places, you know, in the high research, the very pure theoretical research type places, and boy, I'll tell you, there's no such thing as a closed door or a locked door, so we always found our way in. And we'd go up to the library and read all the computer magazines every week, and we found a book on the telephone system, and it had the same frequencies that were mentioned in this article that was called fiction. And we looked at each other and realized that we had stumbled onto something that was not fiction. So we figured out how to build a blue box, and we actually built one, and we could make phone calls anywhere we wanted for free. And we also managed to meet Captain Crunch. But we had a very interesting philosophy about it, a very pure philosophy. We would go out to payphones night after night after night and start learning talk, which is by experimenting. We'd learn how to talk to operators in London and to transfer us over to Tokyo, and Tokyo back to London, London to Tokyo. We started calling all the different dial-a-discs and dial-a-jokes and dial-a-songs all over the world, from Australia to Hong Kong to wherever. And we did this to explore everything we could do. We tried to do something new that we hadn't done before. But when we came back to the dorm, and Steve went back to his home, when I called my relatives, I called my parents, I called my friends, I called Steve himself, we never used the blue box. We paid for our phone calls. I had a very high phone bill. The idea was the blue box was an incredible tool to explore a world of fantasy and imagination, but not to rip off the phone company. You know, also you're a little afraid to make calls on your own phone and get caught.